So on the first day of my introductory computer science classes, I tell all my students that computer science is the study of algorithms. And what an algorithm is a step-by-step solution to a problem, okay? I want to focus on this term step-by-step today with a problem called the Ghostbusters problem. Now you have to use your imagination, but let's pretend all those green dots are ghosts and all the tan dots are Ghostbusters, okay? What we want is we want to have the Ghostbusters shoot the ghosts. We have the same number of ghosts and Ghostbusters in a giant field. And we want to have all the ghosts get shot by different Ghostbusters, but of course, what we don't want to have happen is we don't want to cross the streams. Crossing the streams will be extraordinarily bad and lead to the destruction of the universe and other bad outcomes. So, for you guys, probably for most people, the first thing you would try to do when you're presented with a problem like this is start randomly drawing lines and see what happens. Maybe we put one there, maybe we put one there, la-di-da-di-da. And what usually happens is you get pretty far along, you get to the end, you say, oh crap, I crossed the streams. All right, let's try again. Different lines. La-di-da-di-da, more lines. Here we go. And we get to the end. Crap! I crossed the streams again in the exact same place. So the problem is because if you're doing things kind of randomly, you're doing things not methodically, you can make the same mistake over and over again because you don't know why you made your mistakes in the first place. Okay? So how do we add more methodicalness, add more step-by-stepness to this? Okay? One way is to start labeling things. Okay? And so we can give all the ghosts a letter and all the Ghostbusters a number, and we can have a giant table, and the way to read this table is Ghost A is being shot by Ghostbuster 1, and Ghost B is being shot by Ghostbuster 2, and so on down. If you draw the shots for that with this set of shots, which obviously is wrong, but a different ordering, a different set of numbers, a different permutation of who shoots who, leads to something that actually works. Neat, okay? Now, I got pretty lucky that I found this in my second try, right? Really, the question now is, how big could this table get? How big would I have to make this to have all permutations of who shoots who, okay? So for just 8 ghosts and Ghostbusters, it's not too bad. It's about 40,000 combinations. Not something I personally would want to do, but something a computer could handle without too much trouble, okay? If I go up to just 80 ghosts, the number gets pretty ridiculous. If you're not familiar with scientific notation, that is this number. That's too much for me, that's too much for a computer. I don't have that kind of time, okay? So now the question is, we have a methodical process that will eventually get us a solution. Can we do something better? Can we have some kind of burst of insight to figure out a way to prune this table and make it smaller and find something that has not such a ridiculous amount of things to look at? If you think about it for a little bit, what you realize is long shots are bad, right? That if I shoot across the whole field, I'm more likely to interfere with other shots from other Ghostbusters, right? So we want to have a way to encourage the Ghostbusters to only shoot nearby ghosts and look at solutions that have those properties, okay? So the way you do this is you start in the bottom corner and you think about a sweep of a radar sweeping around. Okay? And what you're going to do as this radar sweeps is keep track of how many ghosts and Ghostbusters you've seen as you go around. Eventually, so 3 ghosts and 1 Ghostbuster, 3 ghosts and 2 Ghostbusters, eventually you'll have the same number of ghosts and Ghostbusters. That's where you stop. Okay? That's going to be a shot. Okay? Then what you've done is you split the world into 2 different parts. One part on the left that has the same number of ghosts and Ghostbusters, one part on the right that has the same number of ghosts and Ghostbusters. And if you think about it, there's no reason for anybody on one side to have to shoot anybody on the other side. So I've taken this and I've split it down into 2 smaller problems. And I can do the same sweeping process over again. I could do the random line drawing. But either way, I can solve each problem smaller, and I don't have to make that giant ridiculous table. Okay? So very quickly here at the end, let's think about what we did. Our first pass was to try a random drawing of lines and see what happened. That was fun, but it was random, it was unfocused, we had no plan, we could make the same mistakes over and over again. Our second try was to methodically try all the solutions, to generate all permutations of stuff, and yes, that will get an answer eventually. This is where I throw in multiples of the age of the universe and things like that out there. Computers are never going to be fast enough. And then our third try was to think about the problem and notice something about it and see if there's any properties that we can use to apply to make our solution work better and faster. And then if we can use that to get an answer, great. And guess what? You guys just did computer science. Congratulations. Thank you.